Previously, we were just discussing compounding interest, but we were only looking at what we call single transactions. A single transaction is a one-time deposit or a one-time repayment of a loan. If you consider how most of us tend to save for long-term financial goals, it's not doing a one-time deposit. Most of us don't have, say, $5,000 to deposit today and let sit for 20 or 30 years. Instead, what we do is we save incrementally. So we'll put away a little bit over a long period of time. These are what are known as multiple transactions. In section 9.4 of your book, we talk about annuities. And we're going to talk about first the growth kind of annuities. So an annuity is just simply formed by making equal periodic payments at equal time intervals. So let's say you're saving for retirement. Okay? Oftentimes what we do is we set it up so we're saving the same amount every period, maybe monthly, over a long period of time. So putting away $100 a month or maybe $50 a paycheck. Okay, so what we're doing is making equal periodic payments and we're doing it at equal time intervals. Mortgages, car loans, when you repay those, you don't repay those in one lump sum. If you did, you wouldn't necessarily need to take the loan in the first place. Instead, when we repay a large loan, such as a mortgage or a car loan, what we do is we make equal periodic payments at equal time intervals. Okay? You have that equal periodic payment set up, right? And your lender is not going to be happy if you skip payments. So you can't really just say, oh, I'm going to give you $300 this month, but next month I'll skip. They want it at equal time intervals. So that's what an annuity is. The periodic payment is simply the amount of each payment. It could be the withdrawal amount or it could be the deposit amount. Since we're focusing on growth annuities here, we're going to be talking mostly about deposits. One last thing before we start getting into some examples is this idea of an ordinary annuity. An ordinary annuity is an annuity, but the payment is applied at the end of each payment period. Now that might not mean a whole lot at the moment, but once we start getting into examples, you'll see why this is an important aspect of the type of annuities we deal with. So with ordinary annuities, it says the payment is made, but technically it's applied at the end of the payment period. So here's an example. A family enters a savings plan whereby they invest $1,000 at the end of each year for 5 years. The annuity will pay 7% interest compounded annually. Find the value of the annuity at the end of the 5 years. Now, up to this point, we've only dealt with single transactions, but that's not what is happening in this example. The family isn't just depositing $5,000 today and letting it sit. They're not making a one-time deposit of $1,000. What they're doing is they're going to deposit $1,000 every year for 5 years. So that's the idea of a multiple transaction, something occurring over and over again. Okay? Now, at this point, all we know how to handle are the single transactions. And this was the formula we were using to calculate the future value of a single transaction. In order to help us understand the periodic transactions or the multiple transactions, we're going to treat each deposit as a single transaction and see what it will grow to. So the family makes their first deposit in year 1. Now here's that idea of ordinary annuities. They're going to make deposit 1, 2, 3, 4, and 5. What you have to understand is that it does not matter when they make that deposit within year 1. As far as the bank is concerned, they're going to calculate interest first, then apply the payment. So in their eyes, this whole account has a zero balance. They give them interest on a zero balance, which is nothing, and then they apply their first deposit at the end of the year. So that first deposit, while you may think it's going to get interest for 5 years, it is only getting interest at the end of year 2, 3, 4, and 5. Fair or not, that's just the way ordinary annuities work. Okay? So when we go to calculate the future value of this deposit, okay, we have $1,000 deposited, 1 plus. Now the rate is 7%, but since it's compounded annually, that's going to be 0.07 over 1. So I'll just write it like this. And then N remembers your total number of transactions. Well, this is going to get interest for 4 years. When we run through this, we find their first deposit will grow to $1,310.80. Okay? But that's not the end of their investment, because at the end of year 2, they make a deposit. Now remember, because it's an ordinary annuity, the payment isn't applied until the end of the period. So the second deposit is going to get interest at the end of year 3, 4, and 5. So it gets interest for 3 years. Calculating the future value of this particular deposit, we come up with $1225.04. So you can see that it grew as well, but just not as much as the first deposit. And that's because the first deposit is getting interest for the longest period of time. Year 3 rolls along, they make a deposit, that's only going to get interest for 2 years. So when we calculate the growth of that money and the future value, we find it grows to $1144.90. Again, we see growth, just not as much as the previous 2 deposits. Year 4, the family makes a deposit, but it's only going to get interest for 1 year. And so that grows to $1,070. Now, year 5 rolls along and the family does make that deposit, but keep in mind this is the end of the investment. So that $1,000 is just worth $1,000. If you'd like to see it by the formula, well, there's your principal. And how long is it going to get interest for? 0 compounding periods. This whole expression is to the 0 power. Anything to the 0 power is 1, so 1,000 times 1 is 1,000. I would probably tend to take the more logical approach. If it's not getting any interest, it's just worth what it is. Now the question was, what is the value of this annuity at the end of the 5 years? Well, here we've calculated the value of each individual deposit. So if we want the value at the end of the 5 years, we can simply add up all 5 of those deposits and get the future value of the annuity. Now this approach wasn't terrible. It only took 5 steps, but imagine this. Most people, when they're saving, they may save monthly for 30 years for retirement. Well, 12 deposits a month, or excuse me, 12 deposits a year for 30 years is 360 separate transactions. Using this approach, if somebody wanted to calculate the future value of their money, they'd have to do 360 separate calculations, and that's just too much. So what we're going to do in the next video is we're going to go through, much like we did for compounding interest of single transactions, we're going to go through and we're going to see what we did to arrive at our final answer, and we're going to generalize it into a formula that we can use to calculate the future value no matter how many deposits we make in a year and no matter how long, how many years this is going to go on for.